Okay, so welcome to altitudes of a triangle. We're going to also the orthocenter when we have all the altitudes. What we're going to do is we're going to find the orthocenter of these triangles. Now this could be a little bit of a longer video. I'm not quite sure how it'll go, so just be prepared. Dun dun dun. Dramatic music. So we have a triangle here and we have the altitudes in blue. The altitudes are the perpendicular segment from vertex to the opposite side. So it's a segment that goes from one angle to the opposite side and it is perpendicular, creates that right angle. The orthocenter is the point where all the altitudes meet. So this is the point where all those altitudes in that triangle are going to meet together. The hard part's finding it. It's easy when you can just draw a picture like this and make it up, but finding it in a real graph takes a little bit more steps than this. So, how to find the orthocenter? First, you have to find the slope from point A to point B or whatever, just pick 2 points. You're going to find the slope between those 2 points. Then you're going to find the perpendicular slope to that. And then you're going to draw the perpendicular slope from C. And then you repeat steps 1 through 3 for the other 2 sides. And then you find the point where they meet. So I want us to remember that the slope equation is y2 minus y1 divided by x2 minus x1, and that the perpendicular slope is the opposite reciprocal of your original slope. Opposite meaning it changes signs, reciprocal meaning you flip the fraction around. So this is going to be a lot of little steps from previous things, not too difficult, just going to be a little bit time consuming and tedious. So let's go. So on this page I'm going to just do the slopes, the perpendicular slopes, and then you see here I have the triangle already drawn. This is where we're actually going to draw in our lines that are the perpendicular slopes. So first things first, let's find the slope for AB. So for AB, this will be x1, y1, x2, y2. And we're going to be erasing this and changing it, so you may want to rewrite these a couple more times, but I will not because I don't have a lot of space here. So from A to B, so we're going to do y2 minus y1, divided by x2 minus x1. So 6 minus 2, so that's 4 divided by negative 2, so that's negative 2. So now the perpendicular slope to AB is going to be the opposite reciprocal. So this is negative 2 divided by 1. Remember, if it's just an integer, it's divided by 1. Now we're going to flip it and change the sign. So it's going to go from negative to positive, and then 2 divided by 1 to 1 divided by 2. So now what we're going to do is we're going to go to this page with C, and we're going to draw in that slope. So it's 1 divided by 2, so 1, wrong color. Two, 1, 2. And then we're going to draw the line that goes all the way through this. And sometimes, as you see here, it does not actually go through the triangle. Sometimes your orthocenter will meet outside the triangle. So now we're going to find the slope from B to C. So erase, erase. This becomes my x1, y1. This becomes my x2, y2. So we're going to do 0 minus 6 divided by 4 minus negative 2 goes to negative, change to a positive, so we get negative 6 divided by 6, which is negative 1. So the perpendicular slope for BC is going to be 1 over 1, which is just 1. But we're going to leave it as 1 over 1. So we have a rise and a run. So now we're going to look at A, and we're going to go up 1 over 1 here. And then we're going to go the opposite way, so down 1. Then I'm going to draw a line through those dots both ways. You can already see those two cross there, but let's just make sure that we're doing this right and go ahead and find the third one. So we're going to erase, I'm just going to erase my x1, y1 and give my x1, y1 back to the A. It doesn't matter really which order you put them in, as long as when you do it you plug it in the right points. So the slope for AC, so we're going to do 0 subtract 2 divided by 4 subtract 0. So we get negative 2 divided by 4, which simplifies to negative 1 over 2. So we're going to find the perpendicular slope to AC. So negative 1 over 2, it flips and changes sign, so it's just 2 over 1. So now we're going to go from B, and we're going to go up to right 1. And again, I need to change the color. Up to right 1. And we're going to go down to left 1. We're going to go the opposite way for a little bit. And then we're going to connect these with a line. There we go. And you'll see right here is our orthocenter. If it's pretty close to a point, feel free to kind of guess. That's fine. For now, you may do some stuff later in upper level classes where you find the exact point, but right now it's just getting this down and trying to do the best. Now again, I know it's weird, this is outside, but that'll happen every now and then. The next one example you do I think is better, but let's actually figure out where this is. So x-wise, this is at 1, 2, 3, 4, 5, 6, 7, 8, so negative 8. And then 1, 2, 3, 4, 5, 6, so negative 8, negative 6 is our orthocenter for that triangle. Said a lot of steps, a lot of little steps with repetition, but not too bad overall. So here I have an example for you to try on your own. So I want you to go ahead, pause the video, and try and do this one now. And you probably ran into this. So you see that you get a slope of 0 here. So if your slope is 0, that's actually a horizontal line. So if what's perpendicular to a horizontal line is a vertical line. So this is going to be a vertical line there. So just so you know that. So I'm going to pause the video again and let you keep working. Okay, so we're going to start here. So I want you to go ahead, pause the video, check your stuff. Once again, make sure that I did it right, you did it right, it all looks good. And then we go here, and I was wrong again. It appears that it is outside the triangle, and it's at negative 2, negative 2. So, but that's okay, we found the orthocenter, we're all happy. So once you're done with this, making sure you know what you're doing, everything going on, you're done with this video.